Hello and welcome to a discussion on simplifying rational expressions. We should have this A on the end of that. That's okay. So if we look at these steps to first complete rational expressions by simplifying, factor the numerator and denominator if possible, and divide out common factors. So if we look at example 1 right here, we have x plus 5 over 5 plus x. Well, through the rules of addition, you can actually manipulate it to look like x plus 5, and then you notice that that's a positive 5. So you can actually just change the position and have x plus 5. And remember, 1 can be written as any term with itself over itself. So we can put these in parentheses and notice that these are the same terms, and that will reduce to 1, just as the fraction 2 over 2 reduces to 1. So the answer for this case is 1. Looking at number 2, it looks like a very similar case, but we have to notice that we have a negative, meaning this variable is negative. So let's rearrange this to look like x minus 2 on top, with on bottom, we'll have to notice that this is a positive 2. So we'll put the negative x in front with the positive 2 in the back part. So now we can use factoring to note that there's a negative 1 in here. If we can take out this negative 1, we can make the top and bottom look alike. So on top we have the x minus 2. And on bottom, if we pull out the negative 1, it's going to turn this negative to a positive, so it's going to make that a positive x. It's going to turn this positive into a negative, leaving you with negative 2. Well, if you look, we can say there's just the 1 in front of this, because we'd just be like multiplying it by 1, meaning we still get whatever we have in the original. So we see that these two are the same, canceling out, or just leaving us with 1. So we're left with 1 over negative 1, which reduces to just a negative divided by a positive, or a positive divided by a negative is still a negative, leaving us with just a negative 1. Looking at number 3, we have 15 over the denominator, 10a minus 5. Okay, now we can factor, and we can think of this as everything is divisible by 5. So if we think of 15 as the product of 5 and 3, and on bottom we see that 5 can go into 10 and 5, so we can pull out a 5, leaving 10 divided by 5 is 2, don't forget our a in there, and then negative 5 divided by 5 is a negative 1. So if we are able to look and see that these 5's can cancel out because there's 1 on top and bottom, we're going to be left with 3 over 2a minus 1 as our answer. Okay, with number 4 we have the fraction x plus 7 on top divided by x squared minus 49. Now actually it's important to note that this fraction can be broken down into, when factoring x plus 7, x minus 7. So we can actually rewrite this as x plus 7 over the set of polynomials x plus 7 is a quantity times the quantity x minus 7. Okay, and I like to put each set term in a set of parentheses. Now we can note that there's an x plus 7 on top and an x plus 7 on bottom. So these cancel out, just leaving you as a 1 as a placeholder. So you are left with 1 over x minus 7 as the solution for simplifying that rational expression. With number 5, we're going to have to factor even more. So on top, we're just going to be left with, again, x minus 1 as a quantity. Okay, on bottom, with the coefficient of 1 in for the x squared term, we can open up 2 sets of parentheses right away, placing x in each set. Okay, note that this has a negative in for the c term, because this was, we can think this a, the x squared term is a, b term just has the x in there with some coefficient, and c has just the regular number. And the sign of c, it's positive. We would go to the sign of b and use both for each terms. However, this is a negative. C has a negative term. So that tells us to use a positive and a negative. Okay, so now we can multiply to give us a negative 4 that we can combine through adding and subtracting to give us a positive 3. So we have negative 1 times 4 would give us a negative 4. How about positive 1 and a negative 4 would give us a negative 4. And finally, a negative 2 times 2 would give us a negative 4. So if we were to combine these through adding now, what would give us a positive 3 through adding or subtracting? Negative 1 plus 4 would give us a positive 3, while 1 minus 4 would give us a negative 3. And combining negative 2 and 2 would give us 0. So this is what we want, because we wanted the positive 3 found in the b term. So you can place a 1 in for the positive and a 4 in for the, So we have the selection of negative 1 and 4. So let's place the 4 in with the positive and the 1 in with the negative to keep the negative there. And so now we can have these broken down. We can say that on top there's an x minus 1 and on bottom there's an x minus 1, leaving you with 1 in each case. We're left with 1 over x plus 4 as our answer. For number 6, we have the terms x squared plus x minus 6 over x squared plus 4x plus 3. So to break this down, we need to break the fraction into numerator and denominator. So the numerator can be broken into, noting that the x squared has a coefficient of 1, telling us just to go ahead and write our x term in each set first. The term of c is negative, so that tells us to write a positive and a negative for each case. And now we have to think of things that multiply to give us negative 6 that combine to give us a positive 1. So negative 6 and, or negative 1 and 6, or 1 and negative 6, or how about a 3 and negative 2, or a negative 3 and 2. And which of these, when adding, would give us a positive 1? Because here's the positive 1 right there for the b term. And I believe you'll see that positive 3 and negative 2 multiply to give us negative 6, but add to give us 1. So 3 goes in with the positive and 2 goes in with the negative. Okay, on bottom we have negative 2 or x squared plus 4x plus 3. So right away we can write our two sets of parentheses, having an x in each case. Okay, the positive tells us to use the same signs found for b, which was a positive, so both of these will be positive. Okay, and what multiplies to give us 3? A positive 3, so that could be a 1 and 3, a 3 and a 1, and that's about it. So it doesn't matter which way we put those, we can put a 1 and a 3 in each case. Noticing that there's an x plus 3 on top and bottom, we can cross those out, saying they cancel out, leaving us with just 1, leaving us with the terms x minus 2 on top with x plus 1 on bottom. And that is our simplified rational expression.